Good morning, boys. I am Shubhrata, your chemistry lecturer. Welcome to my online class. Today again we again talk about chapter 10, mineral resources, metal and non-metal. In this chapter, we discussed two lecture of it. Today we discuss about corrosion. Symptom, causes, prevention of corrosion of certain metals and alloys. All of we know about corrosion. It's a major problem in our daily life. For corrosion, many products can destroy and hamper our normal work. If things made of iron or iron alloy are left in open air for a long time, their upper part produces a reddish brown substance. This substance is called rust. Iron decays by producing rust. Similarly, if things made of pure copper, brass or bronze are exposed in air for a long time, a black, brown or green layer is created. This layer is called copper slag. Copper decays producing copper slag. It's also a things of corrosion. Generally, exposure of pure metal and their alloy to open air for a long time created a difficult colored substance which is known as corrosion. That means if we expose a metal in open air, it reacts with air and water and produces some rust which is called corrosion. Then we discuss the main thing of corrosion. The substance created due to corrosion of iron is hydrated ferric oxide, Fe2O3 NH2O. Okay, the reaction on iron occurs very slowly in steps. In one step, oxidation occurs and another reduction occurs. That means oxidation and reduction are causes in corrosion reaction. It requires oxygen, water from atmosphere, water of the atmosphere converted into H plus and hydroxide ion. H2O converted to H plus and hydroxide. When iron comes in contact with H plus of open air, it donates electrons and turn into ferrous ion. That means if iron donates electron and it will produce Fe2 plus ion. The electron accepted by the oxygen and X plus ion and produces H2O, which is called a reducing reaction by reduction reaction. Oxygen plus 4 H plus 4 electron accepted by this and produces H2O. The total reaction is Fe2 plus H plus oxygen equal to Fe3 plus water, and this Fe3 plus react with hydroxide ion and produces ferric hydroxide. This ferric hydroxide is converted to ferric oxide and 2H2O, 3H2O, and it is the symbol or formula of rust. Now we discuss about electroplating. It's a simple process where a reactive metal and non-reactive metal are in electrolysis cell and giving a layer or coating in the reactive metal by non-reactive metal. Okay, we discussed the electroplating. Generally, the method of laying a coating of less reactive metal on more reactive metal by electrolysis is called electroplating. That means a layer of less reactive metal on the more reactive metal. That means if we have a more reactive metal and coated by a less reactive metal, then this metal will last for a long time. It's called electroplating. In this method, the metal that will be the coating is connected with positive charge of battery, and the metal that will get the coating is connected with the negative charge of the battery. Then the electroplating is done through electrolysis. For example, adding of coating copper or iron. In copper sulfate ion is taken, the copper rod is connected with positive charge while the iron rod is connected with negative charge. As electrolysis is passed in the cell, copper donates 2 electrons which go through and oxidation is occurred, and this electron taken by this 2 electron is taken by the solution of copper ion and form copper and attached to the iron rod. That means the iron rod is coated by the copper ion, and this iron is last for a long time. Then we discuss about galvanizing. The method of laying zinc coating on any metal is called galvanizing. It does not require electrolysis. Zinc is coated anyway on the metal. Then we discuss about non-metal minerals. One of the non-metal minerals is sulfur, which is extracted by Frasch process. Frasch method of sulfur extraction we discuss here. Now we discuss the nomenclature of sulfur. Sulfur is a yellow colored substance. Sulfur mixes are situated deep inside the earth. The substance is extracted from mine by Frasch method. 3 tubes with a single center is inserted into the depth sulfur layer, which is known as Frasch pipe. How to extract this sulfur from the sulfur layer? Here 3 pipes are situated in this process. In the middle line or middle pipe, heated air are inserted with pressure. In the side or the third line is inserted with superheated water. Superheated water means the water which have the boiling point more than 100 because in superheated water pressure is applied. For this water boil at 115 degrees Celsius temperature. Here more pressure are applied. For this, when superheated water is inserted here in the sulfur layer, this sulfur layer molten, and when the air is passed through this middle layer, then here only one line for going the sulfur to upward. That means this line is used for going the sulfur to the upperward. That means when pressure air and superheated water are inserted here in sulfur layer, the sulfur is more melt and sulfur go to this portion, and we get the liquid sulfur. Uses of sulfur. Sulfur is used in large amount of different industries, like we used for preparing of sulfuric acid. It is added to rubber to make rubber more sustainable. The method is called vulcanizing of rubber. Sulfuric acid is used in fertilizer industry. Then we have to know some product of sulfur dioxide, sulfur trioxide, which is used in production of sulfuric acid. Again, we have to know some alloys which are used, different alloys and its uses, which we use in our daily life. Some alloys are steel, stainless steel. The composition of steel and stainless steel are given: brass, bronze, duralumin, etc., etc., and carat, 24 karat gold, 22 karat golds, 21 karat golds, which are used in our daily life. We have to memorize it from our books for our for giving the example or giving answer in MCQ. Thank you for today's class. Please memorize and solve some question from test paper for your own betterment. Thank you.